In this video, we discuss about the second law of thermodynamics. The absence of the process illustrated above indicates that the conservation of energy is not the whole story. If it were, movies run backwards would look perfectly normal to us. The second law of thermodynamics is a statement about which processes occur and which do not. There are many ways to state the second law. Here is one. Heat can flow spontaneously from a hot object to a cold object. It will not flow spontaneously from a cold object to a hot object. Heat engine. It is easy to produce thermal energy using work, but how does one produce work using thermal energy? This is a heat engine. Mechanical energy can be obtained from thermal energy only when heat can flow from a higher temperature to a lower temperature. We will discuss only engines that run a repeating cycle. The change in internal energy over a cycle is zero as the system returns to its initial state. The high temperature reservoir transfers an amount of heat QH to the engine, where part of it is transferred into work W and the rest QL is adjusted to the lower temperature reservoir. Note that all three of these quantities are positive. A system engine is one type of heat engine. The internal combustion engine is a type of heat engine as well as. Why does a heat engine need a temperature difference? Otherwise, the work done on the system in one part of the cycle will be equal to the work done by the system in another part, and the net work will be zero. The efficiency of heat engine is the ratio of the work done to the heat input E is equal to W upon QH. Using conservation of energy to eliminate W, we find A is equal to W upon QH. We can write it QH, heat of higher level, minus QL upon QH. In other words, we can represent A is equal to 1 minus QL upon QH. The Carnot engine was created to examine the efficiency of heat engine. It is idealized as it has no friction. Each leg of its cycle is reversible. The Carnot cycle consists of four parts: isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. An example is on the next slide. These are the four processes which are represented in the diagram. First, from A to B, isothermal expansion; from B to C, adiabatic expansion; from C to D, isothermal compression; from D to A, adiabatic compression. For an ideal reversible engine, the efficiency can be written in terms of temperature. From this, we see that 100% efficiency can be achieved only if the cold reservoir is at absolute zero, which is impossible. Real engines have some frictional loss. The best achieve 60 to 80% of Carnot value of efficiency. Refrigerators, air conditioners, and heat pumps. These appliances can be thought of as heat engine operating in reverse. By doing work, heat is extracted from the cold reservoir and adjusted to the hot reservoir. Refrigerators, air conditioners, and heat pump. Refrigerator performance is measured by the coefficient of performance. COP is equal to QL upon W. Refrigerator and air conditioner. Substituting COP is equal to QL upon W is equal to QL upon QH minus QL. A heat pump can heat a house in the winter. COP is equal to QH upon W. Entropy and the second law of thermodynamics. Definition of the change in entropy as when an amount of heat Q is added, delta S is equal to Q by T. Another statement of the second law of thermodynamics: the total entropy of an isolated system never decreases. Order to disorder. Entropy is a measure of disorder of system. This gives us yet another statement of second law. Natural processes tend to move towards a state of greater disorder. If you put milk and sugar in your coffee and stir it, you wind up with coffee that is uniformly milky and sweet. No amount of stirring will get the milk and sugar to come back out of solution. Order to disorder. Another example: when a tornado hits a building, there is a major damage. You never see a tornado approach a pile of rubble and leave a building behind when it passes. Thermal equilibrium is a similar process. The uniform final state has more disorder than the separate temperature in the initial state. Growth of an individual and evolution of a species are both processes of increasing order. Do they violate the second law of thermodynamics? No, these are not isolated systems. Energy comes into them in the form of food, sunlight, and air, and energy also leaves them. The second law of thermodynamics, the one that defines the arrow of time, process will occur that are not reversible, and movie that run backward will look silly. And availability of energy, heat, death. And another consequence of second law, if any natural process some energy becomes unavailable to do useful work. If we look at the universe as a whole, it seems inevitable that as more and more energy is converted to unavailable forms, the ability to do work anywhere will gradually vanish. This is called the heat death of universe. A macro state of system is specified by giving its macroscopic property, temperature, pressure, and so on. A micro state of a system describes the position and velocity of every particle. For every macro state, there are one or more microstates. Statistical interpretation of entropy and second law. A simple example, tossing our 4 coins. The macro state describe how many heads and tails there are. The microstates list the different way of achieving that microstate. We assume that each microstate is equally probable. The probability of each microstate then depends on how many microstates are in it. The number of microstates quickly becomes very large if we have even 100 coins instead of 4. The table on the next slide lists some microstates, how many microstates they have, and the relative probability that each microstate will occur. Note that the probability of getting fewer than 20 heads or tails is extremely small. Statistical interpretation of entropy and the second law. Now we can say that the second law does not forbid certain process. All microstates are equally likely. However, some of them have an extraordinarily low probability of occurring. A lake freezing on a hot summer day, broken crockery reassembling itself, all the air in a room moving into a single corner. Remember how low some probability got just in going from 4 counts to 100. If we are dealing with many moles of material, they can become so rare as to be effectively impossible. Thermal pollution, global warming, and energy resource. The generation of electricity often involves a form of heat engine, whether it is powered by biomass, solar power, cooling towers, or a feature of many power plant. Next, we will discuss in next video.